Hello everyone, welcome to another video. In this video, what we're going to look on is solving linear equation. We're going to focus on case one that deals with equation containing addition, right? Let's look at some example. So example one, we have a plus 3 is equal to 6. How can we go about solving for a here? Our objective is to isolate a by itself, right? So in other words, I don't want this plus 3 beside a. So how can I transfer this plus 3 over to where 6 is? We can do that by simply doing the opposite of adding 3, which is to subtract 3. But note, whatever we do to one side, we have to do it to both sides, right? So we are going to subtract 3 from both sides. How would you state this in your book? You would state this as a plus 3 minus 3 is equal to 6 minus 3. Note that I have color code this minus 3 for you to easily see that I have subtracted 3 from both sides. At this stage, what are we going to do? We're going to simplify. Note here, when we simplify, all we'll end up with is just a equal 3. How do I get this? Note here that 3 minus 3 is 0, and 0 plus a will give us a, and 6 minus 3 will give us 3. So therefore, your solution is a equal 3. You can always test if a is really 3. If we replace a here in the original question with 3, 3 plus 3 will give us 6. So therefore, our solution is correct. Let's look at a second example. Example 2, we are given b plus 2 is equal to 7. Again, we want the variable by itself. In this case, the variable is b. So how can we get b by itself? We can transfer this positive 2 over to where 7 is. How can we do that? We can do the opposite operation, which is to subtract 2 from both sides. How would you state this in your book? You would state this as b plus 2 minus 2 equals 7 minus 2. At this stage, what are you going to do? You're going to simplify. When you simplify, that will give you your solution of b equals 5. As you can see here, 2 minus 2 is 0, and 0 plus this b will give us b, and 7 minus 2 will give us 5. And you can test it. If b is 5, if we replace this b in our original problem with 5, 5 plus 2 will give us 7. So therefore, our solution is correct. Let's look at example 3. Example 3, we are given 8 equal p plus 5. Now, our objective remains the same. We want p by itself. Now, how can we transfer this positive 5 over to where 8 is? We can do that by subtracting 5 from both sides, right? So how would you state this in your book? You would state this as 8 minus 5 equal p plus 5 minus 5. Note, at this stage, you are going to simplify. When you simplify, that will give you a solution of 3 is equal to p, or you could state it as p equal to 3, right? As you can see here. Now, let's test to see. If we replace p in the original problem with 3, 3 plus 5 will give us 8. So therefore, we know that our solution is correct. Let's look at our last example. Example 4, we have p is equal to q plus 8. Now, again, we want q by itself. How can we transfer this positive 8 over to where 5 is? We can do that by doing the opposite, which is to subtract 8 from both sides. How would you state this? You would state this as 5 minus 8 equal to q plus 8 minus 8, right? Now, when you simplify, what would you get as your solution? You would just get negative 3 is equal to q. But you can always rewrite q on the right-hand side. So in other words, q is equal to negative 3. As you can see here, 5 minus 8 will give us a negative 3. And 8 minus 8 will give us 0. And 0 plus q will give us q. Now we can do a quick check. If q is negative 3, let's substitute negative 3 where q is. And negative 3 plus 8 would give us a positive 5. So therefore, we know that our solution is correct. Now that I am sure that you have understand this concept, Here are some questions for you to try. Thank you for watching and do enjoy the rest of your day.